So here we have our first example. We're going to be looking at the area of the two-dimensional region bounded by the natural exponential e to the x, the linear function y equal to x, and we're going to be going from x equal to 0 to x equal to 1. So the first thing that you're going to be doing in these types of questions and in the next section when we start looking at volumes is you're going to be doing a two-dimensional sketch. So first off, what does e to the x look like? Well, it's going to be crossing over the x or the y-axis here at y equal to 1. Then it's going to be an exponential function, so it's going to look something like this. Let's just fix that a little bit. We also have our curve y equal to x, so it's going to have a slope of 1, and it's going to sort of cross over through the origin. It's going to look something like that. And then if we label these, we have y equal to x, y equal to e to the x, and we want to look at the area from x equals 0 to x equal to 1. So in our scenario, this right here is going to be the vertical line x equal to 1, which means the area bounded is going to be this region right here. And that's what we want to find the area of. So fine. Let's now set up our integral and evaluate it. So we know in general our area always going to be integral from a to b, upper function minus lower. And we are integrating with respect to x. Okay, we can actually go and sort of draw here a sample rectangle on the actual region. That'll help us visualize what we're doing. One of the most important things to recognize is that if it's a vertical rectangle like that, we're going to be integrating here with respect to x because that base width is delta x. So fine, we have set up our basic integral, upper minus lower. What's going to be our upper function? What's going to be our lower function? Upper function will be e to the power of x, and the lower function will just be x itself. Integrate with respect to x. What's our smallest value of x on our interval? It's going to be 0 right there. So our lower limit of integration will be 0. And the largest value of x will be x equal to 1. So that will form our upper limit of integration. And this integral right here, this is going to give us the area between these two curves, the area of that two-dimensional region. So let's actually figure out what it is. We have to do a little bit here of FDC2. The basic antiderivative here is going to be not too bad. We have e to the x minus 1/2 x squared, and we're going to evaluate that from 0 to 1. So what we end up with is actually just going to be e to the power of 1 minus 1/2 1 squared minus e to the power of 0 minus 1/2 0 squared. So really, this is going to work out fairly nicely. We just have e minus 1/2, and then we have e to the 0. That's going to be equal to 1. So we end up getting minus 1 here. And this term is just 0. So really, we end up with e minus 3 divided by 2. And this is going to be area between these two curves. And that is what we get.